Okay, hello everyone in a new video. So we have reached chapter 5, which is the chapter of kinematics, part 3. In this part we are going to solve some exercises considered as a direct application of motion in 2 dimension. So in this exercise they are telling me, given the parametric equations of a moving particle m in a reference system x or y. So here, since the reference system has 2 variables and they are given by x and y, so the motion occurs along 2 dimension. So in number 1, okay, the given is that we have x of t related to time and y of t related to time. We are asked to write down the position vector r. We know that r by definition is given by xi plus yj. So the vector r, the x component, is given by this expression. So at squared plus 3t minus 8 multiplied by the unit vector I plus, as for the y, we have that 100t minus 55. And we don't forget the vectors along I and j, because this is a vectorial equation. The vector must exist on the left and the vectors must exist on the right. So this is the position vector. Recall that these equations are called the parametric equations because they are parameterized by the parameter t, which represents time. This is said to be the quadratic term, this is linear term, and this is constant. This is the linear term and this is constant. Now in number 2 they are telling me determine the trajectory equation of the moving particle m. So the trajectory equation is the actual path followed by the particle, and this is done by determining an equation completely related by x and y and independent of the time. Then in this case we have that x, which is x of t, is equal to at squared plus 3t minus 8, and y is equal to 100t minus 55. So actually we need to get rid of time, then referring to the variable which have only the linear term, which is y, then in this case we can say that y plus 55 is equal to 100t, or in other words t is equal to y plus 55 divided by 100. Now in this case replace t, which is equal to y plus 55 divided by 100 in x. We get that x is equal to 8, so y plus 55 divided by 100 raised to the power 2 plus 3 multiplied by y plus 55 divided by 100 minus 8. So this is the trajectory equation, because it's a relation completely dependent on x and y and independent of time. So it's not enough to determine the trajectory equation. It's better to write what does it represent. Is it a straight line, parabola, or a circle? Notice that it is linear in x and quadratic in y here, because if we expand this expression it will be quadratic in y. Then the type of this, whenever it's linear in one variable and quadratic in the other, then the type of equation is parabola, or the type of the trajectory. Okay, no need to determine the properties of this parabola. Now in exercise number 10 they are telling us, given the position vector of a moving particle lying in a 2-dimensional plane, so the particle is given by m and the position vector is given by r, is equal to 3t squared plus 15t plus 11 multiplied by the unit vector I plus 6t minus 1 multiplied by the unit vector j. So in number 1 they are telling me to give the parametric equations that describes the motion of m, and this can be extracted from the position vector, knowing that the position vector can be written as xi plus yj. Then by comparison we can say that x of t is equal to 3t squared plus 15t plus 11, and y of t is equal to 6t minus 1. So these are the parametric equations. Now as for number 2, they are asking me to determine the trajectory of the moving particle m. So as I have said, the trajectory is a relation completely dependent on x and y and independent of time. Then x, which is equal to 3t squared plus 15t plus 11, and y is given by 6t minus 1. Then we need to determine from one variable t as function of this variable and replace it in the another variable. We always refer to the linear term. So here we can say that t is equal to y plus 1 divided by 6. Now let's say replace t, which is equal to y plus 1 divided by 6 in x. Then x is equal to 3. T is given by y plus 1 divided by 6 to the power 2 plus 15. Y plus 1 divided by 6 plus 11. So this is the trajectory that is dependent on x and y completely. And it's better to specify the shape of the trajectory. Since it's linear in x and quadratic in y, then the shape of the trajectory is parabola. Now as for exercise number 11, they are telling me, given the parametric equations of a moving particle m in the reference system, so we have that x of t is equal to 100 cosine 3t plus 2 minus 5, y of t is equal to 100 sine 3t2 plus 3t plus 2 plus 10. So everything is expressed in the SI. Now here notice that both the angle of cosine and sine are the same. So here we have the angle to be 3t plus 2, and here the angle is 3t plus 2. Okay, so this is important. Now in number 1, they are asking me to write the position vector, which is by definition given by xi plus yj, and we don't forget the unit vectors, the vectors over I and j, because this is a vector relation. Now in this case, the expression of x is given by this 100 cosine of the angle 3t plus 2 minus 5. All of this is multiplied by the unit vector I plus 100 sine 3t plus 2 plus 10. So this is the value of y that is dependent on time, multiplied by the unit vector j. Just give me 1 second. So this is the position vector r. Now as for number 2, they are telling me to determine the trajectory equation of the moving particle m. So whenever the parametric equations include cosine and sine, so there is a probability or a possibility that the trajectory may be a circle. It's not necessarily always true, but in grade 11, whenever the parametric equations include cosine and sine, there is a possibility that the trajectory is a circle. So let's say that x of t is equal to 100 cosine 3t plus 2 minus 5, and y of t is equal to 100 sine 3t plus 2 plus 10. So whenever we are dealing with a circle, we need to remember the equations of the circle. So we have two important equations, and they are given by cosine square of alpha plus sine square of alpha equal to 1, and x minus a square plus y minus b square is equal to r square. So these equations are important. Here you need to be careful that the angle relating the cosine on the sine must be equals. So we cannot say that cosine square of alpha plus sine square of beta is equal to 1. This is completely wrong, in which that alpha is different than beta. Okay, so alpha and beta always must be equal in order for this equality to happen. Now, how do we determine the equation of the circle? So in theory, we will proceed by the same method. We need to get rid of the time. So in order here, we cannot get rid of the time. So in order to do so, we need to get rid of the trigonometric relations that are given by cosine and sine. And to do so, let's express cosine in terms of x, and this is given by cosine 3t plus 2 is equal to x plus 5 divided by 100. As for the sine 3t plus 2, what I'm doing here is I'm dragging the constant to the other side and dividing by this factor. So it will be given by y minus tan divided by 100. Now after we have determined the explicit relation of cosine and sine in terms of the variables x and y, we can say that cosine square of alpha plus sine square of alpha is equal to 1. Here we are choosing alpha to be 3t plus 2. So we can say that cosine square of 3t plus 2 plus sine square of 3t plus 2 is equal to 1. And this is true because the angle of the cosine and the sine are equal. Now cosine 3 of 2 is given by x plus 5 divided by 100. Notice that this power 2 is for all of the cosine, so it's like this, plus sine square 3t plus 2. Sine 3t plus 2 is given by y minus 100 divided by tan, 1 minus tan divided by 100 raised to the power 2, which is equal to 1. Now if I complete this expression here, then it's given by x plus 5 to the power 2 divided by 100 to the power 2 plus y minus tan to the power 2 divided by 100 to the power 2. Now 1 can be written as the fraction of a divided by a, in which a is any number different than 0. Let's choose a to be 100 to the power 2. Simplifying by 100 to the power 2 on both members, we get that x plus 5 to the power 2 plus y minus tan to the power 2 is equal to 100 squares. From this relation we can directly say it's a circle, but we need to determine the center and the radius of the circle. So in order to compare this equation with this equation, we need to insert here an additional minus sign, so it will be x minus minus 5 raised to the power 2. Why I'm doing so? Because the center here is given by IAB. In order to say that A is the center, we need to add an additional minus sign, so this is important, plus y minus 10 to the power 2. Here I didn't add another minus sign because all the minus sign already is present, which is equal to 100 to the power 2. Okay, so from the early beginning here I have decomposed this number as a power. Now in this case we can say that it is a circle, so it refers to the trajectory. So the trajectory is a circle of center I given by minus 5 and tan. So it is given by x minus a to the power 2 plus y minus b to the power 2 is equal to r to the power 2. Now a is equal to minus 5, b is equal to 10, r is equal to 100, and r is equal to 100. Now always all quantities in physics must have a unit, since everything is expressed in the SI, so the radius is expressed in the SI. Here also it's more convenient to write that the center is given by minus 5 meters and 10 meters, but whenever we are expressing coordinates, no need to mention the units, okay? Now the last exercise for this video. So they are telling me, given the position vector of a moving particle lying in a two-dimensional plane to be m to b, this is the position vector. Number 1, they are asking me to write the parametric equations. Now we have that the position vector is given by cosine of the angle, which is 5t square minus 100 multiplied by the unit vector I, plus sine of 5t square minus 100 multiplied by the unit vector j. And we know that in general any position vector in 2 dimension can be written as r is equal to xi plus yj. Now comparing both vectors by comparison, we can safely say that the x component, which is function of time, is equal to cosine 5t square minus 100, and y of t is equal to sine 5t square minus 100. Now in number 2, they are asking me about the trajectory. Since the x and y variables are related to trigonometric relations that are given by cosine and sine, so we must directly think of a circle in which we need to make use of the following equations that are given by x minus a square plus y minus b square is equal to r square, and cosine square of alpha plus sine square of alpha is equal to 1. Now we have that x is equal to cosine of 5t squared minus 100, y is equal to sine 5t squared minus 100. Now we need to get rid of time. Time here is found inside of the angle, inside of cosine and sine, so we cannot solve explicitly for t. In order to get rid of time or cosine and sine, we need to use the famous relation that cosine square alpha plus sine square alpha is equal to 1. Here, because cosine and sine have the same angle, which is given by alpha is equal to 5t square minus 100, then we can say that cosine square of 5t square minus 100 plus sine square of 5t square minus 100 is equal to 1. Now cosine is given by x, so this is simply x to the power 2 plus y to the power 2 is equal to 1. Okay, so I have replaced cosine. This power 2 is for cosine of this. Cosine of this is simply equal to x, and the same goes for y. Then in order, okay, let me say x squared plus y squared is equal to 1. In order to compare it with this relation, we need to write it in this form, which is given by x minus 0 to the power 2 plus y minus 0 to the power 2 is equal to 1 to the power 2. Why I have written it in this form? I have added an additional 0 in order to compare it with this. So simply in this case, the trajectory is a circle of center, which is the origin O, and the radius r is equal to 1 meters. So that's it for me in this video, guys. In the next part, part 4, we will discuss UVRM, UARM in 2 dimension.